the first question a couple people had, and it is what basically, to paraphrase, because a couple different people had the same question, what's left on the roadmap before doing a public release of the compiler? And there's probably more than this. Maybe we'll think up more things as we go on, but there are three main things that come to mind. I'm not sure if I should like put graphics on here. We don't have anything yet on the screen. Maybe we'll do some code or something. I don't know. For now, it's going to be boring. Okay, so there are a few major things that I think need improvement before a public release of the language, and they're all due to basically various corners of the language that are trying to be ambitious and haven't achieved full closure yet. All right, so the first of those is still, and I gave this same answer probably last time this question was asked, is the macro system. We would like to achieve relatively easy Lisp-style code rewrites at compile time where you can rewrite your syntax tree, and people do that commonly and don't feel bad about it. And it's easy to debug, and it's strongly typed, right? Unlike Lisp macro systems, right? And so a lot of the design of the metaprogramming has sort of been with that eventual goal in mind. Maybe it's actually not as important as I had imagined when starting the compiler, because we don't seem to need it that much in the game, right? But that said, it just feels like an important thing to bring to completion. Like right now, you could technically do it, but it's just probably really annoying, so people don't really do it very much. Now, what does that mean? Because I'm not actually working in that space in the application programming that I'm doing, it's hard to gauge, right? It might just be that we need like a good user level module that gives you common operations that people want to do, plus, a couple of little compiler features to like close small gaps. Maybe, maybe it's not that. Maybe there need to be some more major compiler features. I'm not sure. So we kind of just need to go into that space and do it, right? But that's one. That's actually less important probably than these other two, though, because if we end up just never doing that, the language is mostly fine, except for that part. There's two other ones that are probably more important. One of them is cross-compiling support, just improving the robustness and the functionality. And more importantly, just defining better for users of the language what happens during cross-compilation exactly, so that they can understand it and, do good things with it. Like right now, it's sort of magic that I think people just sort of hope works, right? And so the history of this, of course, is that originally, to keep things as simple as possible, we only targeted 64-bit Intel CPUs, right? Of course, we use LLVM as one of our backends, and that gives you, at some level, the ability to target other things. But that tends to also need support at the user level, right? At the language level. And sometimes that is harder to figure out what that should be without complicating the language or making it gnarly or whatever. And then, of course, okay, so the thing that's been implemented, right, which is the thing that we just need to make sure is robust and understood, is the fact that now anytime you cross-compile, there's now a conceptual difference that wasn't there before, right? If you're compiling for 64-bit Intel on 64-bit Intel, then all your code, both your compile time metaprogram code and your runtime code, is all working on the same CPU, which means it can use the same, well, not just CPU, but operating system. Let's include that, right? So the same CPU and operating system. So for example, you don't need to care or think about like what file module you import if you're opening a file at compile time versus runtime, right? So now, suppose that you're at compile time on your Intel machine, and at runtime you're compiling for, the MetaQuest 3, which is an Android ARM device, right? And so it's not just that the target instructions are different, but all the user level libraries have to be different, right? So if you import a file module at compile time, that needs to be totally different code than runtime, because the operating system underneath is different. Android is super annoying about like, are you loading things out of your package or the file system and whatever. So that all just has to happen, right? And so there's this difference now where we have a system for just making that go, right, at compile time, where there's an extra workspace that you don't see directly, right? And that workspace gets imports of, host things. And it pretty much works out, although there's probably some corner cases. If we really were to stress test it, there's probably some things that are not fully ready for prime time there. But, it works really well. Like I just spent several weeks doing development for the Quest 3. And all our part of it went well, right? The annoying part of it was all the like Android tool chain stuff that like is super broken and like can't even copy files reliably or start the program reliably or any of that stuff, right? But our part of it was actually fine for day-to-day development there. But just because I'm somewhat familiar with the internals of that, Raphael actually did the programming for that. Because I'm somewhat familiar with the internals of that, I know some things that should get updated there, in order for it to be as useful as possible for the widest number of people. Okay, so that's item number 2. Item number 3 is that right now, one of the strong features of the language is that we have this runtime context, right? That's the first implicit parameter passed to procedures in a C++ way, but it's better than what C++ does. And that's all good until you try to use a DLL, for example, a dynamic library, shared object if you're on the Linux operating system or the Mac OS. And, part of the point of a dynamic library is that it's compiled at a different time from your main program and isn't necessarily synchronized with it, right? And so the problem is that right now it is quite possible, and in fact common, because the compiler compiles things out of order and the order of user level context entries is like actually not deterministic right now because it depends on just like thread operations. There is now some friction anytime you call into a DLL, right? Which is that you and the DLL have different ideas of what the context is. And we have a little bit of a user level Band-Aid for that right now. I don't love it. I would like to do something much more automated. And the question is, what's the best version of that? That's still fast and doesn't cause problems, right? So the easiest thing to think of is just, when you're a DLL and you generate code that accesses the context, you do something that uses more indirection to like figure out what the member is that you wanted. But there's also, what if the member that you wanted does not exist in the main program, but you want it to exist in your DLL and have a default value? What if vice versa, right? That's got to get handled. And then also, what if there are callbacks from the DLL back into the main program? When a DLL calls another DLL, how do you make sure that some table is set up for that exchange to happen correctly? And so I think that version of things will probably work okay. It's just we have to design it and figure it out. But that's actually, most people, I don't actually recommend DLLs because they're just so broken on modern operating systems. But for some use cases, you really just want them. And you also want to interoperate with things that exist. And so, this is a good thing for us to fix. But those are what I would say are the three main things. I'm going to put... I'm just talking here. Let's just put some code on the screen. I don't know. Hey, we just talked about cross-compiling. All right. That's question number one. Okay, and there were some add-on questions to this. Will there be any passive normalizing, standardizing the way the functions in the bundled modules look, including making basic into more coherent stuff? Probably. Okay, people can tell me what they think needs harmonization the most. One thing that I'm very aware of is that some of the functions in BASIC are prefixed with what they do. So for example, dude, I'm fat fingering everything. If I go into array here, right, these are all prefixed by array underscore whatever. And that's in part because when we started the programming language, we didn't have function overloading, or it was very early, right? And it's just like, look, we need to do some array stuff to have a program. And then since then, because this is widely used, we haven't really changed it, right? But this kind of goes counter to one of the ideas of the language, which is that if you give people really good importing and namespacing tools, that you don't need all this prefixing, right? And they can do whatever they want. And if they need to resolve a name conflict, they can do that on the import, for example, right? And all that functionality is in, it works. I don't actually use it very often, in part because a lot of this stuff is prefixed. But there's this interesting thing where it's like, I don't necessarily want to give myself problems that I need to solve that way by making these names more generic. Okay, and then there's one other thing. Well, okay, so some of these function names are a little imprecise. This is called add. It really should be append, right? Add is, I think, a little... I don't want to have a bunch of overloads for the word add. Append is probably better, right? But here's the thing. Okay, so and part of what this question is asking is probably this, because other modules, if you go into them, don't have this kind of prefixed way of naming their things. And in part, that's because in some modules, names are naturally much less ambiguous, right? Like the sound player module or something, you've got, free stream entity pass. Like, that's just not a very generic name, so we don't feel the need to prefix it. Okay. Now, so which way do you harmonize it? I would prefer to harmonize away from prefixes, because that was part of, again, the whole point of all these features is you don't have to do this, right? But it is, the reason we haven't done it is there's just a question in my mind about whether consistency is better, or just whether sometimes you want a prefix and sometimes you don't, because some names are more helped by prefixes. Now, all of this sort of hammers on another one of the core decisions of the language, right? And this is maybe where there's room for some creativity. We'll see, right? And that is, we decided not to be object oriented and all this stuff. And that makes us a lot simpler in that part of the language, the part that involves calling functions and types of functions and stuff. And, we spend that complexity budget elsewhere in places like metaprogramming and whatever, right? So that's been a very useful thing to do. However, it does mean, there are some cases where we have large numbers of overloads of functions. Like if you say init on something and you get the call wrong, you get an overload resolution message, and, I probably in the game that I'm working on, you probably could get at least 50 matches for that, right? That you want to figure out. And nobody reads through all those matches when there's that many. It sort of raises the question of if that's a useful thing to do, but you sort of do. You do want to report all the locations, I guess. We probably should sort them better, like alphabetically by file or something. But so the reason I bring that up is that, for example, the more you go into your core modules and you make the names things that could be more ambiguous, the more pressure you put on that point. And right now, I don't find it to be very bad. Once in a while I do something where I get a long overload resolution message, but that's pretty uncommon. But you would be making that more common. And then that raises the question, well, maybe that means we shouldn't make the names more general. Maybe it means we should do something better for overload resolution. Maybe it means we should do something else for name spacing, right? Because there are a couple other things people there's the standard thing about why can't the hash table see my comparison operator or whatever? Because we have this large amount of hygiene, right? And the reason for that is we don't want to stumble into some of these problems that other languages have, where the behavior of your program might change as you add code. Now, that said, there's just trade-offs, right? There's trade-offs to all this stuff. One thing we could do, we could add some namespace that lives somewhere that everybody can see, and then you explicitly put things in that namespace. That solves the hash table question. It doesn't solve this. So there's just related questions. You know what I'm saying? So that's what I'm thinking about that. We could have a conversation specifically about that at some point, I think. But yeah, that's what I'm thinking. But I do think that certainly it's worth doing a pass over everything to make it easy to think about, right? The question is just, what is the target for that, right? Both in terms of naming, in terms of parameters. Parameter naming styles is maybe less, is maybe already more consistent, I would say, but sometimes, there's questions about that. So, for sure that will happen to some degree. The question is just, what is the target? It needs to get figured out. Is there any schedule for public beta? I'm not operating on this in a schedule way right now. I wouldn't mind having a specific schedule, but there's a lot of things that make timing random right now. All right. So someone says, this is going to be a contentious answer that I'm going to give. The main feature missing for me in the language is support for a cross-architecture way for expressing memory ordering for multi-threaded programs. I mean something like a mechanism to assign semantics to memory operations, e.g. is sequentially consistent, acquire, release, relaxed, that many languages have adopted to limit what memory operations can be reordered by the compiler and insert the barriers needed by the architecture. As far as I know, the only way to express atomic multi-threaded primitives is through inline assembly, but it's not clear if there are guarantees across the compiler front end and the back ends that no reordering can happen. I think something like this is very useful to code correct multi-threaded data structures that are portable across architectures with different memory ordering semantics. Okay. So part of this question, it is absolutely true that in order to program correctly in a multi-threaded way, you need to know, like, there needs to be I'm trying not to use, like, I'm thinking of words to describe this, but they're all loaded words from other languages. So I'm trying to think of a quasi synonym, right? You need to be able to know what's actually correct, right? There needs to be a right answer to what do I do here in order to achieve this thing, right, multi-threadedly. And make sure, for example, that compiler optimizations aren't going to mess up my program, right? So that absolutely needs to be there. That is there right now. It's extremely implicit, right? And so you kind of have to just like trust it right now. And it should be made more explicit. That is all true. However, the start of the question sounds like the questioner is saying, are you going to put something like the C++ memory model or whatever? And my answer to that is no, because this is one of those things about modern programming that I think makes all these languages too complicated and just leaves a bad taste in my mouth, right? I don't like any of it. The programming language should not have a memory model in that way. So the difference is, for people who don't know what I'm talking about, at some point, and I don't know when this happened, maybe it was very early in C++'s history, right? But at some point, C++ people decided that, like, oh, C++ is like an engine or something. It's not like C. C is a programming language that lets you use tools to target different operating systems and architectures, right? So like in a C program, you'll use an if-def for a particular CPU or for a particular operating system and whatever. And those tools are obviously all still there in C++, and people use them in the real world. But in the C++ committee design world, they're thinking of it differently. They're like, C++ is like an engine. So you write a program for C++. You don't write a program for a target CPU or operating system, right? And that's why C++ just gets really, it gets super complicated, and there are lots of reasons why it gets super complicated and gnarly, but one of them is they're trying to insulate you from the real world along all axes, right? And the problem is when you do that with regard to something very fundamental like access to memory and how it works and what that means, you're too far from reality on something that's too low level, actually, right? And so I don't want to do that. I don't want to have like a general like math nerd memory model that you're programming to. Instead, it's a very operational, work person oriented toolkit. Like, this is a barrier, right? The compiler can't cross this barrier and whatever, right? I think a much smaller set of those things than some of these languages have is in practice all you need. And if you needed something else, so the thing is, a lot of these things are kind of ridiculous anyway, right? So, on, like, if you're programming on a 64-bit Intel CPU, reads and writes from the cache just work a certain way, right? And like trying to pretend that you don't know that causes a lot of problems and doesn't really solve anything, right? Okay, so, but the reason we haven't gone and made all these things explicit again is, I mean, in part because it's a lot of work that we don't exactly need to do yet. And also because just, you know, we're working in priority order, right? Like in reality, lots of our, you know, like all the things that I work on from day to day at the user level are relatively heavily multi-threaded, right? And so in reality, the system that's in place works, right? The problem is that users of the language don't have insight into it, and so they don't know what is the right answer to how I should write my program so that it's correct, right? And so that's what we need to do is sort of evolve the design of that so that it's more legible, let's say, and make sure it's the best thing, right? Which, by the way, I would say that has to happen before public beta as well. So that's thing number 4. That's thing number 4. All right. Yeah, I mean, the end of the question again says, I think something like this is very useful to code correct multi-threaded data structures that are portable across architectures with different memory ordering semantics. I mean, that sentence is kind of fiction, kind of, right? Like all these super loose memory ordering things that are in C++, nobody uses them because it's what they found is it's almost impossible to write a correct program with relaxed memory semantics. Like, I mean, I've never tried to do it, but the conventional wisdom is it's a complete nightmare and don't do it. And so I kind of feel like that's fiction, right? I'm going to get another tea. I'll be back in a second. Sorry for the delay, but my voice is getting a little dry. Well, I wanted another one of those teas and didn't have one. Ran out. Sad. Okay. I feel like there was a related question. Oh, so one of the things he said, this is an issue I can talk about that touches on another one of the questions. One of the things he said was, as far as he knows, inline assembly is the only way to do synchronization. That's not quite right. We currently have a compare and swap intrinsic that we put back in. We used to have more intrinsics, right? And we took them out in favor of inline assembly. But the problem is, especially when you're trying to write startup code or just code that's trying to be very general, it gets really complicated if you have to start writing assembly per CPU, right? And just having some simple intrinsics for things that everybody supports is just a better way to do it. So we actually took out compare and swap for a while, but it's back in. If you look in like modules preload, we do it somewhere. It has a bad name. No, it's in runtime support. Where is it? Yeah. We call it log comp right now, which is not a good name. But so here's the thing. There's this general question somebody else asked. What's the model for assembly language programming going into the future? Are you going to keep going with the current model? Are you going to do something more like intrinsics? And the answer is I'm not sure. Certainly intrinsics are useful sometimes, like I said, especially if they can be portable. And you're not being hyper specific about the results, right? Like, does this set a flag on the CPU or whatever? Which CPU flags are going out of style anyway, whatever. The thing that makes it a complicated question is that at some level it kind of doesn't matter almost. Like, intrinsics and lines of assembly are, functionally interchangeable. It's just a difference in attitude. Like if you say we're going inline assembly, it's like the attitude is that we care much more about specifics of individual CPUs, and much more about the programmer having exact control of the exact instructions, right? And if you do intrinsics, you're taking an attitude that's like, well, you just want to get some things done, and you're maybe not trying to be as instruction level efficient as possible, but the number of cases in which people actually want to be as instruction level specific as they can is very small. And maybe for those, we just let you write an assembler, right? So we already do that. We have an intrinsic, it's a compiler directive. This is basically the same thing, that lets you just insert raw bytes into your program, right? So you can do that. So that could be one potential direction, is to move the assembler to user level. So right now we only have an assembler for Intel, right? Which is, again, sort of one of the issues. If you do ARM right now, we don't give you inline assembly. And if we went with a more intrinsic based system, then, you would need to have a system of like, these are the intrinsics that work everywhere or most places or whatever, right? But it might actually be more useful for more people than what we're doing with inline assembly. That's the question. Now, the challenge, if we moved inline assembly to user level and said, hey, this is a user level thing that people do, we have this problem where now interfacing between inline assembly and the rest of a function becomes much more difficult, maybe, or we would at least need a huge standard for how that works, right? So way back in the day of 32-bit Visual C++, right, they had this cool inline assembly where you could just use the variables from your C++ function parameters and all that, and it was very smooth and very integratable. In Microsoft, all the PhDs working at Microsoft were unable to maintain that as we went to 64-bit. And so that's a ripperoonie for them. And so that's one of the things we wanted to bring back, was this easy ability to refer to parameters of your function and easy integration. And with the current inline assembly, you have that, right? If we go to a more user-level inline assembly, it's unclear how to make that work. Although, to be honest, I haven't spent a long time figuring it out. So, yeah, that's that question. Okay, we got a comment in the chat here. I'm the person who asked this last question, the question about the memory models on Discord. Perfectly understand your criticism of overcomplicated C++ library features. But in my experience, the memory ordering stuff is pretty reasonable. It was also adopted in C and Rust, and I use them professionally multiple times with good success. I don't know if it's the best model, but it's definitely a working model compared to other C++ that is stuff that is completely bananas. Okay, here's what I would say. And again, maybe this is something we could have a preliminary conversation about on the Discord in like a design session or something. I am not convinced about, for example, having compiler directives for memory ordering semantics, right? I think that's unnecessary complication. But if people feel like there are use cases when that's actually better, we could talk about it. And we could also say, what does this do for you? And how does that, are there some other ways that we could do that? I'm very skeptical about buying into current programming language dogma, because I think a lot of it is just being done really without questioning what's happening, but also there's like an aesthetic for simplicity that a lot of programmers used to have. And that's almost completely lost now because nobody grows up even seeing it anymore. But I think it's very important when designing these systems to have this driving impulse, like an aesthetic where complicated things are disgusting, right? That I have that. And a number of my friends have that. And most programmers seemingly don't, but I think you need that to design good systems, right? And so the disgust reflex goes off a little bit when I read about memory models, right? However, compiler barrier, very useful, right? And you don't want to have to litter your code with explicit compiler barriers. So what do, right? That's something that I think we should talk about and attempt to come up with a good design. Maybe you don't need, so here's a thing, right? CPUs do way more instruction reordering than they ever did, right? At runtime. So like a lot of this code motion that people used to do kind of doesn't matter as much on modern out of order CPUs. So you could just put more restrictions on what kind of code motion the compiler does by default. And that might fix a lot of problems anyway, right? I don't know. Now, the problem is then if you go port to some CPU like the mill that has the opposite philosophy that leans on the compiler to generate good code, then that decision could bite you. So we need to see. But I'm definitely always in favor of designing for the reality of computers that we currently have, as opposed to like some specter of all computers that might exist, right? If we design for things that we have and then some radically different CPU type happens, we could modify the language later. That's no big deal. I mean, no big deal. It could be hard, but we've done hard things. Someone says, don't know if you saw, but I posted a while back a basic version of the user level inline ARM assembler. Wow. Okay, I didn't see that. If you want to email it to the email address, which I won't say right now for fear of getting spammed, I'll take a look at it and we'll see if it makes sense to distribute to people. And we could also take a look and see if we could start adding some level of further ways to tell the compiler things, like how do you provide debug information to the compiler about the code that you generated, right? I mean, that's the thing. So, if you can make an assembler at user level, you can make a compiler for your domain specific language at user level or whatever. And that would be nice. I mean, at some level, it's people getting excessive, but you know what I'm saying. Okay. Someone says it's not quite enough to feel disgust. One needs to also have enough skill to be able to find a better, simpler solution. Kind of. But the thing is, The lower the skill level, dude, I have felt unskilled plenty of times in my life, believe me, right? The lower the skill level, though, just time ruminating on something makes up for that. Or just like the amount of effort you put toward working on something or thinking about it. And the more disgusted you are by a situation, the more effort you're going to put in. So it actually does help, even if your skill is not where you wish it were, which I think is the case for most people. Probably everybody on planet Earth. It definitely doesn't make sense to ship. I mean, it might be fun to ship just as a thing where it's like, this is not officially supported, but this is for playing with and talking about the future of this kind of feature in the compiler, right? We could ship it for that reason. Okay. We're not getting very far through the questions. We're less than an hour in. We're fine. Is there a way to make the compiler emit vex prefix instructions instead of default SSE ones? This is a little bit of a different issue because this isn't talking about explicit assembly. This is like... this is talking about the x64 backend. Yeah, the x64 backend is pretty limited. It's not very smart about code generation. So you want to try that on LLVM, right? So one of the reasons we maintain LLVM as a backend is it's got optimization, right? That's better than the optimization that we do so far in our own backend. And also, it's just supports more targets and all that. Now we pay a very dear price for that. Like LLVM is way bigger than it should be, and it takes a long time to compile and all these things. And so that's sad, but it does provide a lot of useful functionality. And so, it is what it is. But try it on there. Let us know if it's not working and we'll fix it. Someone says, I have a lock-free queue in my project and I've got several bugs with assembly reordering in it. The current way for me to validate the queue is just to run stress tests. No, I mean, so like what I said, if you're doing something like lock-free programming, there are compiler barriers right now, or at least, again, like I said, they're invisible to you, but there are around things that need to be atomic, right? Now, if you think you can do lock-free programming without any atomics whatsoever, I would caution you that you're probably not correct, okay? I mean, it sort of depends on the exact specifics of what you're doing, but right? And so, but the reason, okay, lock-free programming is kind of a misnomer on modern CPUs anyway. So for example, assume you're on 64-bit Intel, right? There are locks at the CPU level that are happening, right? So if somebody else writes to a cache line and you try to read from that cache line, right? The CPU will stop you from doing that until the data gets moved over to where you are, right? And the reason for that is, again, because it was found that nobody could write programs that worked when that wasn't happening, right? I mean, there's probably something you can do. You can probably put the CPU in a mode that doesn't do that. This is not my area of expertise, so I never mess with that stuff. But the point being, there are locks happening at the CPU level, right? If you use atomics, right? If you use lock comp exchange, there's a lock right there, right? It's a CPU level lock. It is not a mutex at user level, but there's still a lock, Okay. It's a more efficient lock, but it's still a lock. So it may be a more efficient lock, maybe not, right? Um, but um, this idea that you can just be like totally freeballing it and writing data structures that don't use these kind of operations is it doesn't really work, right? You need barriers of some kind. Let's put it that way. And in this language right now, the way that you get those is by using these operations that have them explicit or implicitly built in, right? Um, if you're trying to do something besides that, it's extremely sketchy. Okay. Yeah, the problem with LLVM is it's just, I mean, LLVM became successful and now there's an army of programmers working on it, right? Like the army of darkness is typing code into LLVM every day. And that just has predictable results, right? What are you going to do about that? Okay. I believe some time ago there was a discussion about structured notes. Are there any plans to add something like this? Yeah, the original plan for notes, you can put notes on declarations and stuff, was to make them strongly typed and structured, because the reason is if your notes are just text and a module is using notes for stuff, how do you know that you're interpreting your note and not the module's note and all that? But like, here's the thing: we don't really have modules that use notes right now, so that doesn't really come up because modules can't really declare stuff that runs in the meta program right now. You almost could, like we certainly, so if we added a convention, for example, that the default meta program would look for like code directives tagged a certain way. And if it sees those, it would insert it into the meta program and run it. Then modules could add stuff that looks for notes and all that, right? The problem is there's no synchronization mechanism for that, in the sense, I don't mean like multi-threaded synchronization exactly, just like, because we compile out of order, how do you make sure that the meta program sees that before you compile any declarations that might have these notes on them or whatever, right? And so that's just one of the things, like, because we don't have header files, right? If we did, there would be a whole thing about that, how that works. Maybe there could be a directive that's like, I don't know. We would need to add something, and anytime you talk about adding something, it could complicate things or whatever. So the upshot is, because nobody really does that right now, text notes are in practice fine, except they're annoying to the extent to which you have to parse a data structure. But like, who puts complicated data structures in their notes? I don't. But that was on the roadmap the whole time. I think maybe sooner on the roadmap than that is just that people would like to be able to put notes in more places. That's definitely something that I've heard. Again, I don't really need to put them in more places, but sometimes people want to. And the problem is, if you could put a note on an arbitrary expression, then the way they're stored and the way they're indicated syntactically may need to be different. So we would just need to look at that and figure it out. One point of confusion a lot of new users seem to run into is how poke name works. For me, the feature feels a bit jank. Yeah, it is a bit jank. That was just a temporary feature that was introduced to give people a way to work around the namespaces being so clean. It's not really intended to be a long-term feature. So the thing that I mentioned earlier in this conversation quote unquote conversation about maybe having a global namespace that everybody can see uh, would be a higher level, possibly cleaner way. And so the way you say like scope module or whatever, you would say like scope global, and you would put things there. The problem is, again, now you can break your program by putting too much stuff there. But there's actually not that many ways to break the program. The main way would be to introduce an overload that defeats somebody else's overload more specifically. And maybe there could be a provision for that, right? But B, the fact that you would be doing it explicitly just still puts us in a fundamentally better territory than someplace like C++ or whatever, right? Where the global namespace is polluted by default and you end up with all these problems. So, yeah, I mean, that's one of those things where it's like, yeah, we'll do something better for that later. Like poke name was never intended to be a long-term thing. Okay. Yeah, so he goes on to propose like a scope poke idea. Yeah, but we would make it look even more like scope export and scope module. It would just be like, well, okay. You could say, so what I just said about scope global is like if there's a very specific scope, but maybe you just want to be able to put something into various arbitrary scopes. And so there, yeah, we would just need a way of designating those scopes. For things like module scopes and all that, it's probably not hard if you bound the module to a name when you imported it. For stuff like file scopes, it's a little more annoying because you would be referring to the scope with a string of the file name probably, because there's not necessarily, unless we provide a way to put a name in the file scope by that file itself, but then that still only allows cooperative insertion, right? Like I could put this thing in this scope. Actually, there's already a way to sort of do this sometimes, right? Like if you have something that you can see, like it's a symbol that gets exported to you somehow, right? For a while now, you've been able to say, hashtag insert comma scope. I think that only takes a code directive. Anyway, there's like things that almost do it, right? And so again, the challenge is rather than adding more stuff to just like add more features that do this, what we would like to do is just harmonize and change these features so that they have the most functionality with regard to addressing other namespaces. And again, I think I would like the ability to do a non-cooperative namespace insertion. That probably can't really happen with something like a struct, again, because that causes compilation order problems. But like something like a file or module namespace or something. Again, like I think it's good to be able to, patch stuff in that file. Well, I don't know. I mean, like without modifying the source code, I was going to say. But then the cases in which you can do that and it's well defined may be limited. Because again, the way that you would be able to say, hey, hold up, don't finish compiling this yet, would be by putting something in that file, right? So like placeholder directives do that right now. Like placeholder says, hey, hold up, don't use this symbol until this declaration gets filled. And the problem is, if you're completely outside something and you can't put an indicator like that, what even happens? There would have to be some mechanism for like top down inserting a block into an arbitrary place in the program that the compiler sees very early during compilation and that is guaranteed to prevent all compilation in that module from happening. Such mechanisms do kind of exist, or like not such there is a concept of that kind of timing in the compiler because it's used for add context, like, but add context is weird also. So we would need to talk about it, and it doesn't actually seem like the most important thing. So probably what I would just do is either the global namespace or some other thing like that helps a lot of use cases without being a big gnarly thing that people have to think hard about, right? Okay. Printing is kind of verbose, especially when adding format specifiers. I was thinking about improving this by implementing C-style format specifier shorthand attached to the argument instead of the string. Do I think that's a good API? I mean, so we've been staying away from C-style format specifier. It is exactly, it is true and correct what this person is saying. Printing is kind of verbose because, like, if you want to format a float, let me find. I'll show you. Most people won't show you the bad things. I'll show you the bad things, right? So, for example, let's go. What? Okay. So if you want to do like, okay, I don't know why someone is calling format float with no arguments. That was probably someone not paying attention. But, if you want to do like %4.2f or whatever in C, which is very brief, right now it's like, okay, this is quite a lot, right? There's two reasons why. Now, one is we're not really trying to be brief here, right? So if you have a format that you do commonly like that, you can just make a function with a shorter name that does these arguments, right? And then you would be like FFL, right? So it's not actually that verbose if you have things that you like to do. But maybe if you don't have things that you like to do and you're like flipping around all over the place, it could get complicated. I mean, here we're basically doing, 4.2. No, these are all 4.2. It's just longer variable name. So you can make a function for that to shorten that right now. The reason we didn't dive in with a design that does that in the print function is because we're printing a much wider array of data types, and some of these types have a lot more configurability. So one of the things we can do, I'm trying to think of, let me go see something. Okay. So here's a very simple example of the opposite of this being extremely brief and good, right? So here we say log error, a non-area marker, whatever, was designated as a camera target, and there's no type specifier on this. What is this? This is actually an entity, right? Area marker is a marker entity. And what's happening is, if we look at print style, right, which is in the context when you use this module, the basic module, you can put a struct printer hook like in there that then understands anything global to your game. So what happens is when we print an entity, this just sees the entity and like does something nice, and you don't need to put a format specifier there, right? So um, that's the good thing about doing things this way. Now, the question is, can we improve it to sort of be the best of both worlds? I mean, you could make an argument like, well, printing floats is so common that you should do it. By the way, there's another thing you can do, which is if you're gonna print a bunch of floats in a certain style, you can make a format earlier in your program, and you can just assign default format float to that format, and then you would be printing these floats. Where was that again? It was in post-processing. This is the wrong one. Yeah. If you did that right, it would turn this line into just this, right? Which is again cleaner and more functional in a certain way. So the giant pain in the ass with C format specifiers is that as soon as you want to have dynamic format, like you want to adjust the number of digits at runtime or whatever, then you have to have like a pre-thing that printfs your format string with %a.b. It's like %d.%d, and like it's a nightmare, right? And it's annoying, and you're probably mallocing that, and everybody's sad. So you don't have any of that here if you do this that way. Whoever wrote this code didn't do it that way, and that's why I brought up an example of the verbosity, right? But so I would say that even though there are ways to make this short and nice for things like floats, it's like still a little bit high effort, or people don't know about it or something. So it doesn't tend to happen. And so the question is like, what do we do there to like grease the wheels a little bit? Do I think that's a good API for you to try implementing? I mean, part of this design is that whatever you want to do in your program is for you, right? If you want to have a convention that you like, if you want to do 4.2f all the time, and you don't want to set the default formatter like I just said, I mean, you could say, you could make an FF, right? And that's like, it's a couple more characters than the C style, but it's not in the string. So like I said, it doesn't have all the disadvantages. And so if this is a convention that you want to do, that's great. Like, we're not trying to tell you how to program, right? We're trying to give you things that you can customize and adapt to how you want to do it. And so like, that's totally, if you want to do that, that's great. Like I said, you can set the default format. The issue about setting the default format is just, what if you sneak a function call in here somewhere that somehow generates a string that doesn't expect the default format to be set? It's like, I don't know about that. I don't know about that. That might be something that we could do something about in the future as well. Let me kill my modifications here. The other reason you don't really want the format string, again, this becomes more complicated. You don't really want the format in the string when you do internationalization, right? Or at least it becomes more complicated and annoying the more junk there is in the string, especially again if you're dynamically changing some of these things based on the language, right? It's cleaner to just have it in code and not string. All right, there's a discussion here about printf. So I already answered the abstraction over SIMD intrinsics. Well, I'll answer that a little more and just say, I could see a future in which we add back a lot more intrinsics. Yeah, I mean, I'm not sure. So originally I was like, hey, we're going to invest in inline assembly and just go that way. Now I feel like the right move might be to invest in letting users do assembly with whatever assembler they want, and adding some intrinsics so you don't have to do assembly, because it is a giant butt pain if you have a module and there's just like a bunch of assembly for everybody's platform in it. That's not simple, right? We would like to be as simple as possible. Like, how do you modify that module if you don't understand the assembly language for everything it supports, right? That's kind of tough. And so we would like to minimize that kind of thing, I think. And so that vision of how we're going to use assembly seems to me like it's changing. Someone's asking about, you said, feel free to skip this, but are there any plans to address release and distribution a bit more completely, possibly with more options in the default meta program? About, like, for example, if you link a DLL, you need to make sure that the DLL gets distributed with your program or nobody could run it, right? So things like that. I had initially assumed that we would do something to make that all very smooth, and we haven't done it yet. What does that mean? Does that mean we should do it, or does that mean we should leave it to people? I'm not sure. One of the suggestions in the question is maybe using the default meta program to do more of that stuff, possibly. I have been reticent to bloat the default meta program because it gets loaded every time you run the compiler, right? And so the more we put in there, the more stuff we're putting in the way of everybody. But, you know, there is also, like, that's a constant battle that I fight, is like, look, how useful is this for people to have to have the functionality versus how much does everybody pay every time they run it, right? And maybe making it more modular, right? Like maybe maybe if you don't invoke the option to do packaging, we don't load the packaging part of the default meta program. That might be a thing that we could do. I don't know. Again, could be complicated. Someone's asking about higher level stuff. Does the Sokoban game have controller support? If so, does it use the input module or the gamepad module or something else like the SDL bindings? Okay, here's the thing. We do have gamepad support. We use input and the gamepad module. We use input for keyboard and all that, and gamepad for gamepad. I don't know why gamepad is a different module. Like, I think somebody ported our gamepad code from our older games, and they just made it a separate module, which kind of makes sense, but not really, because, like, why? Why is it different? Like, why do you need to use, like, direct input to read a gamepad, but use Windows events to read the keyboard? Like, it doesn't actually make any sense. The reason for all this is just historical accident, right? Like, there wasn't gamepad support when that API was made, and then they didn't really unify it, right? So, I'm not sure that gamepad should be a separate module. I don't know why we wouldn't just put all that in input. On the other hand, maybe it should be a separate module because of some reason that I'm not thinking of. I don't know. But I would like to look at unifying those and simplifying it. Okay, here's a fun one for the Linux people. Do you have plans on investing into improving static executable story with the language? At the moment, I have my own sort of metaprogram plugin Crutch to let me build executables against Muscle instead of glibc because I want to run them on lightweight Alpine installations, and it works for me, and it's amazing that compile time metaprogramming is flexible enough to let me do this, but would be cool to have something more integrated / first class. And I know it touches upon the forever beaten horse of Linux distribution portability linking horrors, and I know this is mostly irrelevant for graphics applications, but I wonder if you have any plans related to this. Yeah, okay, so here's what I would say. Back when we started this compiler, I was under the seemingly mistaken impression that there was something that we could do to generate a Linux executable that would run everywhere, right? Like, if you just don't use libc at all, or use a libc that doesn't really use libc, right? Like that just calls kernel functions and stuff, that'll be portable everywhere. And maybe that's still kind of true, but the thing that I've heard is that muscle libc isn't really that, like it won't run everywhere. Like our plan was originally, or at some point, to have the compiler just target muscle or something like it, and then you make things that run everywhere and you don't worry about it. But the problem is, I didn't do this work myself, but when I attempted to delegate the work, people told me it wouldn't work that way. Now, maybe those people were wrong, or maybe it actually isn't really possible, right? So this is, again, this is a problem with the operating system, right? The people who make the operating system are hostile. Well, long ago, were hostile to the idea of you being able to distribute a binary, right? And now, the idea that you could distribute a binary is like such rocket science that you're an idiot if you would ever even try it, because obviously operating systems are so complicated that you couldn't possibly do that, right? Never mind that the binary is the actual specification of your program. Someone is saying use Cosmopolitan libc in chat. I don't know if that's correct or accurate. If people know of a correct answer, let me know, right? If there is a correct answer for what the compiler can do to generate binaries that will run on every Linux, then we would be happy to do that, right? And maybe that just means literally we have to write our entire own libc from scratch or whatever, right? I don't want to do that right now, but that could happen. The thing is, that also doesn't totally solve the problem, unfortunately, right? Again, because all these things are like incompatible with each other. If you want to link a library, like if you just want to simplify your build process and get the benefits of this language, if you're going to link a library written by somebody else, that's going to be a binary input to your program, because you don't want your compile process to like be invoking GCC to compile something every time, right? Although you maybe could if you wanted to. I don't recommend it. And again, the problem is, what is that library compiled against, right? And it's like a complete disaster because there just aren't standards for these things. And famously, Linus was really unhappy about this going way back in time. I'm pretty sure he's resigned to it at this point, right? But like, he was unhappy that user space is so mutually incompatible. The problem with writing a libc, see, here's the thing. In principle, writing a libc would not be that bad. Like, we have our own equivalent of libc here and for our language, and it's great. And it's a lot simpler than any libc you've ever seen and all this stuff, right? The problem is that libc has a lot of the complication baked into it. And I mean, I think you could make a libc that's a lot simpler, and maybe one of these like Muscle or Cosmopolitan is, but like if you look at the history of libcs, whether they're from GNU or Microsoft or whoever, they're a complete nightmare. And there's no reason for it. It's like relatively simple stuff that it's doing, but they're just a complete nightmare. So I don't know. Okay. When simp 3D happens, do you see it being its own module, or will it be a parameter for simp? I'm imagining it would be a parameter for simp, but I'm not sure, because if it adds so much complication, like, you don't want people who just want to do 2D stuff to have to think about 3D at all, right? We could maybe make it some kind of a wrapper module that rides on top of 2D simp and adds a bunch of stuff, right? But you don't see the source code for it if you're stepping through 2D. That might be the best. We'll see. It's one of those things where I would start doing it and then see what's the best way to design it. Do you have anything special planned for the 10th anniversary of the compiler in October? You know, I don't know, man. I kind of just have a lot of work to do right now. I'm not sure what would be good, but if people have ideas, they could let me know. It's my understanding that 32-bit support for the compiler was not currently planned. Is that still the case, even in the far future? In the far future, we could think about it. The thing is, I just, like, we've listed some stuff that we want to improve already during this conversation. And just my policy the whole time has been to focus effort in places like that and not create, combinatoric frictions until as late as possible. So, like, we didn't support more than one CPU or we did Linux and Windows for a long time, but we didn't do Mac. We didn't do ARM. Now we do both of those, right? Because the compiler got to a certain point. It does cost us time and energy to support those extra things on a daily basis, right? We pay for that. And so we don't want to pay more than we have to by adding more and more things. The big thing about 32-bit support is it maybe adds a big piece of uncertainty into thinking about your program that doesn't currently exist. Right now, all pointers are the same size on every platform everywhere, and you just know that when you write your program and it feels really good. If we go to 32-bit, like, ideally you would like 30 pointers only to take 32 bits of storage, right? In data structures and whatever. And all of a sudden that reintroduces back some of this stuff from C about, like, well, who knows how big my struct is? Right now, if you see a struct in this language, you know for sure exactly how big it is and exactly how it's laid out. There's no question, right? And that's very good. And so starting to reintroduce some of this ambiguity is actually a big step that I wouldn't take lightly. Now, you could imagine a half-step version of it where you support 32-bit CPUs, but your pointers take too much memory. I don't know. Like, we could think about that sooner than the other version. But neither of those is happening too soon because, like I said, we just have these other issues. Someone's asking why 32-bit. I mean, a lot of embedded systems are 32-bit. A lot of enthusiast systems are 32-bit. It's just, they won't go away. 32-bit will be around for a while. Fat 32-bit support, yeah. Is having a partially optimized compilation on the roadmap? Yeah, I mean, I don't think that's not on the roadmap of has to get done before we release the public beta, but it is on the roadmap of things we would like to do, of like specifying optimization level per function. Yeah. It's not even that hard. It's just, again, about deciding, like, how it's expressed, like what's the best language semantic for doing that. How do the compiler's performance metrics compare to what we're targeting for the official release? I mean, compile speed, we're still targeting being substantially faster than we are right now. We're still, I mean, it depends what computer you run it on or whatever. But if you don't use LLVM, we're still somewhere, depending on what month it is and whether we've slowed down the compiler or sped it up, we're still somewhere in the range of like 100,000 to 200,000 lines per second. Probably more toward 100,000 these days because, again, we've been working on features and not speed, right? We would like to be at 1 million lines per second. I think that's achievable. It's, again, just, though, it's a matter of priorities. It's like, do we fix the semantics and make those better for people? Like, what do we do first? Let's put it that way. If you mean runtime speed, we're not benchmarking super seriously right now, but it's just, you know, our code is, for the most part, competitive with what we would compile anywhere else when we optimize with the LLVM backend, which is not that surprising, right? Because, you know, we're leveraging those optimizations that a lot of other systems are leveraging. So, yeah. Must the compiler be completely publicly released? Could we not go into an intermediate point where beta users get source access and pull request rights and the rest just the distribution? That way it wouldn't be as much work keeping the project on course. Yeah, I mean, one of the reasons, there are two reasons not to do a public release very soon. One is public release imposes a lot of friction and locks down design decisions, right? As soon as you put something out there and say, hey, everybody use this, you can't change things, which means you can't really make them that much better. You know, without doing another revision of the compiler or whatever. And then the other reason is just, you know, putting pollution into the environment. I'm trying very hard not to do that. Now, of course, nothing in this world is completely perfect. And so at some point, you want to push the button, right? And what I've been thinking is actually something along the lines of what was described in that question as an intermediate phase, right? Like eventually the compiler is completely open source, but there would be an intermediate phase where it's like open binary. We just give people the binary, but not the source. And of course, all the user level code, because you need that to compile things, but not the source code yet, just because we don't want the friction of dealing with that. Who knows? It might be that you get a lot of complaints and feel the need to give people source anyway, but it would probably still be limited in that way. I don't know, but that is an intermediate phase that's easier to administer, and so I'm assuming we will do that at some point before the full open source release. But again, I'm not attaching dates to that. Are there any plans to support proprietary render APIs through compiler modules? I mean, we already do, but again, if you're asking us about compiler modules, like people can make their own compiler modules and distribute them. Like that's fine. Question, DLL calls go through C call directive. That's not strictly true. The calling convention is separate from whether it's a DLL call or not. It's just that most of the code that you probably see calling into DLLs is calling for C or C++ API. What can I tell you about this process and can it be done more clearly? I mean, I don't know that there's anything ambiguous about it. What happens is you have a function declaration. That declaration says what the calling convention is on it. And that determines how it's called. I mean, if there's confusion about that, let me know what it is. I don't think it's super confusing, except the one thing that might make it confusing is right now, when we use the LLVM backend and when we use our own backend, we have different calling conventions. And it's because we haven't decided for sure what we want ours to be. Um, and so that, of course, means if you compile things with the L or with the x64 backend and like try to DLL call into them from something compiled with the LLVM backend, right now it's incompatible. That's not a good thing. Um, in the long term, it'll be sorted out, but it's like, our x64 calling convention right now is um, kind of placeholder anyway, and it's not like the C++ calling convention is so complicated. It's not worth trying to resolve this issue by emulating that, because you would do a great deal of damage to the future of the language, right? So it's just something we got to work out. I mean, unless you feel like the advantage, because in reality you want to link to a lot of C and C++, the reality of compatibility might be seen as beneficial enough to make that worthwhile. It's just, that's not the way we've been making decisions for the entire history of this language, right? We've been making decisions in the direction of cleaning things up. And so I'm loath to do it there. But maybe that's a thing that we need to work out before a full public release, right? Because, like, again, people start distributing DLLs, like, and you have inconsistent calling, that's not great. I don't know. That said, the history of Unix, like when I was in college, your calling convention would change like with every compiler release on the workstation that you were on. So like it's not like the history of computers didn't have that kind of thing. We need to make that decision. Okay. Will thread local variables ever be a thing? I don't know. It's possible. Like people sometimes want it, if not least to just port things that use thread local variables, right? I would like it if they can be user level completely. I'm not sure to what degree that's possible, but if we could provide a user level library that does most of it, then maybe that's fine. I'm not actually sure that that's possible, though. We'll see. I don't like, I mean, I've used thread local variables enough, but I haven't thought super deeply into the details of their implementation to know exactly what has to be where, right, for them to work correctly. Now, okay, the questions we're seeing are now since the start of the session, so we may get references to earlier things. Regarding name updating harmonization, there was an idea you spitballed a while ago regarding the compiler having automatic syntax updating via metaprogram hooks. Is that going to be the official? Yeah, that's still the official plan. The official plan is we do a syntax rewrite at some point. It may not be that big of a rewrite, but yeah, like if we want to change what some operators do or what their precedence is or whatever, that can all be provided in a metaprogram. Have you considered scoped imports? This is currently possible if you name the import, but not if you don't. Yeah, I don't know. Here's the thing. The way that imports work right now, there are multiple issues about them. One is they deduplicate, right? Which is easy if you think about them as just importing into your module scope or your import scope, which is technically above the module scope. Right? So like, you obviously want that to happen inside functions, but like not if you import them into slightly different scopes, etc. So like that's annoying. Right now you actually can say import inside a function and it will only do the import if the function is not dead code eliminated, which sometimes is a really good useful feature. However, is a little bit error prone because you might think your module is good and then you try to compile some program with it that dead code eliminates that function, and now a dependency of the module is now not there. So that's a little sketch. So there's some things to streamline about that, I think. I mean, I'm not that concerned about it because you can do the import by just saying using name colon colon import whatever. So in some sense, what you're just asking for is a real like a very small syntactic tweak. Oh, the other thing I was going to say though is you don't necessarily want to do that in a bunch of functions because you make name resolution a lot more expensive. And you introduce conflicts a lot further down the scope tree. So like if you're importing a module up in some scope, right? You shadow that both with your files variables and your local variables. And this is intuitive, and this is how people expect their program to behave, right? If you put an import in your function, are you shadowing your file scope variables with that? Are you shadowing your parameters with that? If not, how does that even work in terms of the data structure? It wouldn't work in terms of the compiler's current data structures. It might be made to, but right? Whereas if you put a using, like anytime you're using something, it's obvious that the names go right there. So I think that's more understandable and legible to programmers. So my answer would be I don't currently plan. It seems like a question of personal preferences rather than a case where something is obviously better or worse. Okay. How do you think about the boundary between tooling and the language? Oh, I skipped one. Hold on, but we'll do this. When you design the language, do you think about the future tooling ecosystem I'd like to see and include, exclude things based on that? Yeah, I mean, in general, I'm trying to design this language to maximize the ability of users to interoperate with it and to communicate with it and understand things about your program. So that's why, the Codex View example gives you this visualization of your program. That's pretty useful already, even though not that much work has been put into the visualizer, right? And that just runs from the metaprogram, right? It's a plugin to the default metaprogram, so you could make your own that's better or that does different things in whatever. And that's just an example, right? The things that I've said about putting the assembler at user level is another example of going further in that direction, right? And in general, like there's nothing new about that. Like for the entire time that I've been in computers, there's always been this idea that good engineering means you have a core that's smaller and well engineered and does useful things, and then you let people build on it and expand it, right? It's just that like sometimes that model actually doesn't work, but also sometimes, or most of the time, people are, even when they think they're doing that model, they're insufficiently disciplined about it, and they just end up building all sorts of crap into the core thing or whatever. I'm certainly not minimalist. Like this is not at all a minimalist programming language. Because this is one of the ways that philosophy has gone wrong sometimes in the history of computers, is that, sometimes when something's in the core understands it and can treat it more competently and more efficiently and give better error messages and whatever. Whereas if something is at user level, maybe it's not as good. So like something in the type system or whatever, like you really want the compiler to understand that, right? But there's other things that are better done outside, right? And again, the history of software, especially for the last couple decades, has been that like just any old garbage gets added anywhere. And we're really trying not to do that as well. Question: language has already made a huge positive impact on my programming life. Well, I'm glad. I'm curious, has it impacted my own projects? Would love to hear some unexpected benefits. I mean, I'm a lot faster programming in this language than I ever was in C++, and I'm a lot happier programming in it. It's just so much nicer to do things, right? And you could say that maybe that's obviously just it's the programming language you designed, so obviously. But I mean, other people say they feel that way too, so that's great, and that's the goal. The goal is just to make something that is nicer to use than what you see all the time. Is Clojure still on the roadmap? Yeah, it's probably not on the roadmap of things that are required for release. Um, there is a roadmap of step by step of how we put closures in, and like I said, it's probably in one of the earlier Q&As, exactly all the details of this. So I don't want to go too much into it again, but the underlying features that would let us implement closures are also useful for other things, which is why that would happen. Um, this questioner says the only time I was sad recently was when I couldn't use quicksort because I needed a variable from the outside. Okay, here's the thing. You can emulate closures anyway by using add context and putting stuff in your context. And that might seem gross. I mean, okay, well, if you're not multi-threaded, you can, of course, just do it C style and use a global variable, right? But if you are multi-threaded, dude, the word histogram is misspelled here. Who is writing these comments? If you are multi-threaded, hold on, this is a modified file. Let's reset the file. If you are multi-threaded, you can do it by adding to context. Or again, if we have thread local this would be a use case for thread local variables, as you wouldn't need closures for that, right? But you can do it with add context. It's just a little bit gross because you don't need this thing in most of your program, but it's probably fine. Okay. When you work on the language syntax, how do you plan on measuring, assessing what would be best? I mean, that's a complicated question. I just do it the way that I do game design, which is you're trying to globally optimize, right? You're trying to weigh all the factors and come up with an optimal solution that is also pleasant and good and not that complicated. Because complication is one of the parameters, right? But like I said, I'm not sure that syntax is going to change mega heavily. I think there's definitely... So we talked about harmonization of function names, for example. There could definitely be harmonization of other stuff. So we have this thing sort of inherited from C where, we use hash to sort of mean, like in C, it means preprocessor, right? And here it more means like compiler time directive because we don't have a C preprocessor. I was going to look for, but it's not always at the start of the line here. So you can say, for example, if complete, right? Or is constant. Maybe it's not. Maybe it's this. Yeah. So there's some other things. Oh no, that's a variable name. Maybe we don't use is constant in this program. But anyway, the point being, there's some, okay, well, size of and whatever, right? So size of is a compile time operation, but it doesn't have a hash in front of it, right? And why is that? It's because when we started doing the language, it's like size of from C, but I put an underscore because our naming convention's a little different, right? So you could imagine a harmonization about having all compile time operations put a hash in front. That said, maybe that's puts too many hashes in your program. I don't know. Right. So, but these are the kind of things that we would think about. We might change some of the operators a little bit. Like there's still some stuff to clean up about the dereference operator. Um, but yeah, I mean, you just try to. It's a design problem, right? And design is really interesting and deep, actually. What happens if SHTF and somehow you can't work on the language anymore while everything is still closed source? Um, I've made an arrangement with someone to push the button to open source it if I become incapacitated. So that's the answer to that. There is an emergency button that could get pressed. Um, what is the current roadmap for making cross compilation support nicer? You maybe missed the beginning of this because this was actually one of the first things I said. Is that we want to do that. You want to be able to target ARM64 Linux. Current standard module support is limited on this front. Yeah, so there's sort of two issues. And one we've mostly cleaned out and finished, which is the proliferation of inline assembly for x64 made it difficult to compile for ARM. That is pretty much solved in most modules now. So for example, like I said, I was just working on a game for an ARM VR headset, and I could make a whole video game on there with the modules that we have. So that part of it is good. The part of it that maybe isn't there is, static ifs in various corner cases of like, what does this operating system do for this API or whatever, right? But you could actually let us know what problems you're running into. So cross compilation is definitely, it's a newer aspect of the compiler. And it's one of those things where I've used it heavily now, and it works great for my use case, but there may be use cases that like poke on corners of it that are not as done. And so let us know what those are and we can address those. Very interested if there's plans to do native vector complete syntax that maps directly to wide operations like in shader languages. Okay, here's the thing. Here's what I think about this. Like, parallel programming is obviously not just the future, it's the present, right? But what we've ended up with is this heavily mediated parallel programming where people like write AI stuff that like there's a lot of heuristics about how it gets auto vectorized. I mean literal AI code, because that's what GPUs target now, right? Nobody cares about graphics anymore. The thing is, this whole like 4-wide SIMD thing is not like, dude, I was doing 4-wide SIMD in 2002, more than 20 years ago, right? And it's very limited, right? So like if I were to be thinking about what are the most important issues in this GPU style of programming, there's like, okay, there's intrinsics on the CPU, which also could be 4 or 8 wide. We'll talk about those in a second. Or we'll talk about that now. We'll just say that's folded into the discussion that I had earlier about should we do more intrinsics or not, right? I could see doing those at an intrinsic level if we felt there was wide enough support among target CPUs. Should we change the programming language to be vectorized that way? I don't feel like it. I feel like 4-way, 8-way, or any fixed size like that is way too ephemeral and limited of a thing to design your language around. Like, we're already not doing that, right? Like, your actual GPU already doesn't really do that. It just, the shader languages still have it because it was convenient historically for colors to have 4 components and for matrices to have 4 rows or 4 columns. That's why it's like, it's not because 4 is the best number, right? It's because those specific operations got a lot of use out of 4. which is no longer true for the vast majority of, like, something that's evaluating a neural network, right, doesn't give a shit about 4. They want way more than 4, right? So, you know, I wouldn't design a language that way. I would look more like, if I was trying to do that kind of parallelism, I would be more about like directing wave fronts and whatever, right? And what does programming look like? So this language is still very much designed for this model where a core, an execution core, is a relatively heavyweight thing like you have on a CPU. What GPU people call cores is a much more lightweight thing. Casey actually has a really good video. Let me see. I haven't watched it yet, but I assume it's good because it's a Casey video. Okay. So maybe it's this one. I don't know. Zen, CUDA, and Tensor cores. Just explaining the differences between these different kinds of cores and like what they do and how big they are. Although this is from a few days ago. I thought there was another one from a couple weeks ago. So maybe slightly earlier. But you could watch this to get an idea about the differences of it, right? So like CPU cores are very different from like, GPU cores, etc. And GPU cores, etc., AI cores are much, much smaller things that do a lot less. And so orchestrating them looks really different. And that's the thing is, I don't want to defocus this programming language by suddenly going off and doing a bunch of other stuff that's all for that. But that is what I would do if I wanted to be good about parallel programming, right? I wouldn't make a bunch of like 4 wide things. That's just pretty old at this point, I think. People are saying that video is good. Yes. So you can watch that. It's at Computer Enhance. It was just posted a few days ago. Very educational. But yeah, I would say we're just not really trying to do that kind of a language. Like, it's hard enough to do this kind of a language. Okay, when I get sarcastic, and I've actually said this to Casey one time when we were hanging out, I said, I agree that modern compute is all about this highly granular thing, but like, we still don't have a good language for CPUs from the 1990s. And so like what I'm trying to do with this language, well, and later, right? Like you can extrapolate that into a modern Intel CPU, but it's just to say you could graph the place where programming languages went off the rails to sometime in the 90s. And our systems languages just didn't keep track from that point, right? And so like, I'm trying to get us back to 1990s technology, actual good 1990s technology, before we try to go to 2020s technology, because that's just a whole different thing that I don't even claim to understand that well, that deeply in an intuition kind of way, right? So I'm just being limited in my a standard way to ruin things is defocus the mission, right? And I don't want to do that. Okay. Haven't had a chance to use it yet, but really happy you added a key binding module. Was wondering if you'd consider adding something like your Sokoban serialization module that supports versioning of structs. I would find this just as useful. Yeah, here's the thing. I feel like people would find that really useful. I also, though, I'm not sure how to do it in a way that's general, that doesn't turn into a giant bureaucratic mess. That doesn't mean it can't be done. Maybe I just haven't thought about it enough. But I'll put it this. So my first foray in this direction, and this was deliberate, was I picked a simpler task and I did a deep copy module, right? So we distribute that. We've been distributing it for a long time. 2017 is when I added this, right? And I also started using it in the Sokoban game. And deep copy does what you would expect. It goes through a tree of stuff and copies the things as necessary and deduplicates common pointers and stuff. And it's not that long. It's 286 lines. Okay. However, I then tried to use this in the animation system for Sokoban, and it was already going crazy and copying more stuff than I wanted it to, right? There's this danger about imperative or self-referential data structures, let's just say, or not even recursive and self-referential, but just like complicated data structures. Sometimes you want to do different things at different parts of it, and as soon as you abstract out part of it, it's just easy to get it wrong. I don't know, but I didn't work that hard on that problem. All right. Now, the way that the web world does this is they just go maximum dumb and they serialize literally everything into like JSON or whatever, right? And that's incredibly inefficient and horrible, but also it doesn't handle a lot of people's use cases. Because like I just have data structures with pointers in them, right? It's a systems language. What are you going to do? How are you going to help me with this pointer? Like non-managed pointers, right? So it's just a problem that would need to be solved. I do think it would be a very useful thing to provide people as a standard that you knew that you could just use. Like if I could just say, hey, write these data structures to this file, that would be great. And I could add fields and all that. The thing is, there's also the way that we do adding fields and stuff, there's some frictions involved in that I am happy to take because it simplifies the system. But you kind of would want to get rid of those for a generalized version, but then that introduces landmines because it involves... So one of the frictions is when we define an entity, I'll show you. Because we mainly use this for entities. We can retarget the code to other data structures, but like entities saved in save game files and in the world is the main use for this, right? So right now we can version tag fields about like what version did they start? If they finished, what version do they end? But we don't ever delete them from here because the order in which they're stored is necessary to parse the thing, right? So we need to know for the rest of time, unless we bump the version number to something incompatible, which we do sometimes to clean things up, we need to know for the rest of time that this member used to be there, right? Now you could imagine other ways of factoring this out and putting it in some augmentation structure, but that's also error prone all of a sudden. Like it's extremely simple to just leave this in the place in the struct where it is. Okay. So the thing is, okay, so let's hold on. Before I go further into this versioning discussion, you could just do the version without versioning, right? Just let people serialize and deserialize and it doesn't track versions. That by itself would be a simpler task and pretty useful, but it has approximately the same problems as the deep copy problem, which could be solvable. I don't know. Okay. Versioning gets more complicated. So if you're not going to do this, if you want to try to remove this kind of friction, you would maybe be more like a debug file for an executable where you have an actual data footprint alongside the file that describes the format of each version along with the names and their locations. And then you wouldn't need to maintain this information because it would be in the file. However, that's, that takes up space in the file. I don't know. I don't totally love it. We do have something a little bit like that already. So we have a thing, this isn't necessary. we have a thing called the type manifest um, that maps basically the names of all the entity types to integers, and then we just use the integers for efficiency, right? When we talk about what things we're loading. Um, so we do have a little bit of a like a descriptor section. Do we want to make that bigger? I don't really know. The thing is, this is fine for our use case, and so we do things this way still. Yeah, and there are other standards out there. So there's like flat buffer and proto buff and whatever, and we could look at those and see what they do. But my impression is that nobody has really solved this problem in a way. Here's one with nicer formatting because it's a data structure that I defined instead of another programmer. Um, but my impression is that nobody has really solved this for systems languages in a way that I would have liked. Right? You, in order to get this automation, you have to buy into all this ugliness that happens in the web world, and I don't totally want to do that. I'm going to skip annoying questions. Do you think it is a good idea to allow notes in function argument lists? Yeah, this was another question about like, so these are notes. These are the fabled notes we were talking about before, right? You put them on declarations and on structs, but you can't, for example, if we go down to like a function, you can't say make this purple. This would be an easier place to put notes. This is just a parsing issue because this is actually a declaration, right? So that's something that we could do without too much trouble. The question is, what if somebody wants to make this purple, right? That's just like a general expression. And that's what I was talking about before. It's like, oh, I don't know, man. I don't know. Maybe. We'll see. Are non-integer indices for array subscript operator overloading a possibility? That's just something we intentionally don't do. So what this means is, can you say array sub hello? And the answer is you could in principle, because this can be an overloaded operator. In fact, it certainly can be an overloaded operator right now. We just don't allow the argument to be anything but an integer. And that's just for consistency. Like, it's for understandability of the program in some way. Like, this is meant to be, you're subscripting something that's basically an array. It's not meant to mean hash table lookup or store the string hello on a hard drive on the moon, right? But that's just, is that like how fiercely do I hold that to be the right decision? I don't know. Not that fiercely. It's something that we might change in the future. But for now, we just don't let you do that because. So one of the reasons Lisp had, right, when they gave people all this flexibility, is the Lisp community kind of started to disintegrate because everybody did all their own mega domain specific languages that nobody else could understand. And you had this Tower of Babel effect, right? We don't want to do that. We already sort of don't do that by virtue that we have a much more structured syntax than Lisp does, right? But still, there's minor versions of that, right? There's the thing in C, like when C++ operator overloading first happened, you would go look at all these C++ programs and they would like overload all these things to mean things that you had no idea what they did. And it was stupid, right? And so it's a version of that. It's like, let's be a little bit restrained. But yeah, like that's not the decision I feel the most strongly about. Is it possible to make a procedure that can print all variables used in the code block parentheses scope? Um, Usually you would do that from outside a function, not inside the function. Um, because there's just all these problems that come up. Like you need to compile the function to have that information, but if your generation of the information affects the function, you have like a circular issue, right? That's why, most of the metaprogramming involves observing things from the outside because we're able to compile them and then do things. Now, you could probably put something in your function that references a table of known type that is filled at the start of runtime or at compile time by your metaprogram. You could do it that way, probably. Any plans for something like table literals? I know that tables are not part of the language like that. Yeah, we have hash tables, but they're user level. It's not like Perl where they're built in, right? But I feel like they're very convenient to have. I don't know what you would use a table literal for, honestly, because tables are for large amounts of data. Like the whole reason you use a table as opposed to an array is because it's slow to look things up because there's really a lot of things. So why do you want a literal for that? Is that like a carryover from things people do in JavaScript? Can anyone tell me? Why would you want a table literal? Do you just mean because you want to specify 5 key values in some ways? I mean, I would do that with an array and a key value struct or something. I think it's from Lua. Okay. What do people use small table literals for in Lua would be my question. Because that's not a use case that I've literally ever wanted to do. Question, is it a priority to drop the necessary dependency on the C runtime library for compiled binaries memcopy, memset, memcomp? I don't think we depend on the C runtime library for those things anymore. If there's documentation, that used to be true. If there's documentation that says that that's true, it may be out of date. That said, I may also be remembering incorrectly. Let's look. What is the definition of memset right now? Dude, this shows you how much I've been programming at user level, right? Okay, memset's a compiler intrinsic right now, which means that we generate the code for it. So it shouldn't have a libc dependency. If it does, we should prioritize that because I don't want to depend on libc for this stuff. It's not good. But yeah, we used to call into libc for math functions and all kinds of things, and we've been removing all that, right? Someone says their productivity is quite high now. Debugging is still difficult sometimes. What makes debugging difficult? Because I just use Visual Studio or Remedy or whatever. Remedy does have some problem understanding our debug information for some reason. But Visual Studio doesn't seem to. I don't know what the deal is there. I haven't tried Rad Debugger yet. It's on my list. Is there going to be a way to discover modules made by third parties? Here's the thing. You already could make a metaprogram plugin that does that. Someone actually did this. Someone in the beta did like their version of NPM as a metaprogram plugin, I believe. I mean, not like NPM with all the bazillions of features, but like that core idea that there's a server where modules live and you can look them up. Like someone can basically build that, and if there's roadmaps in the way, we can look at resolving those. Are notes always going to stay as strings? I answered that earlier in the video. On the array subscript operator question, could it be possible to allow things that are integer adjacent using enums as array indices, for example? Right. So you can use enums right now, but you have to fully qualify the enum type. You can't use the implicit dot like we're using here, for example, right? Because arrays don't, that's not a thing. Could we do that? I imagine we might be able to just automatically do it if the array is declared, So if you're going to declare a fixed array, you might say num things, right, of thing, right? If this were a fruit or something, right, you have a fruit enum and you say array num fruits thing, that would be a thing where we could attach this type to the array very easily, and then you could do the implicit dot, which is a small convenience, right? But nice. The thing is, the way we declared enums these days, you don't generally have this. Right now, it's a little bit of a cumbersome thing, but it's one of those things that's cumbersome, but also, much more general and pretty useful. But you can say, run enum, I forget, it's, it's something like that. It's not the right function name, right? The problem with this is, I don't know, maybe this doesn't strip the type. The current version of this strips the type and gives you a number, I think. But we could make a version of this that returns you something cast to that. The thing is, it would be out of band of the enum, right? Like if you have, raspberry is 7, you want to return cast fruit 8 from this function, right? And that's like technically out of bounds of the enum, although that's not an error to do that. It's weird, but we could look at that. I mean, it's one of these questions again of how much complication do you add for a minor convenience, which I tend to be conservative with. Okay, we have reached the end of the questions here. I've been going for 2 hours and 15 minutes, so I think that's long enough. And if there are more questions, we can just do them next time, because I'd like to do these regularly again. All right, thank you, everybody. I would like to say I only had 5 hours of sleep, so hopefully my answers were still cogent. I went to bed. People were watching me stream last night. I went to bed with a good 10 hours, and then just sometimes I just have a lot of energy and just wake up in the middle of the night and do stuff, and that's what happens. So hopefully I was able to explain things well enough. We'll do some more of these, probably approximately once a month. It has to be a little loose because I'm traveling sometimes and whatever, but we'll do them as we do them.